Now we're going to take a look at absolute value inequalities. These are really going to look a lot like the absolute value equations, except that they've got the inequality part, which means that we're going to graph the solution set, and we can actually write that solution set in interval notation. So here's number one. I've got the absolute value by itself, so that's still the first step. Make sure that that absolute value gets by itself. Once it's by itself, I can write the inside over here on the negative side, but again, when I make that negative 11, this inequality has to switch. So it follows the same rules as when I was dividing by a negative before. So I change that to a negative as the answer, and then the inequality has to switch too. So I get 2y minus 3 less than a positive 11 for the positive side. So the difference also with inequalities is the symbol in between. So this is a less than symbol. When I look at a less than symbol, it's a less and, less than, less than. When I go, let's say here with number 4, this is a greater. This would be a greater. It tells us the difference between the and equation and an or equation. So when I type, or when I write this out, what I end up having here is an and that goes in between here. Well, a couple things that tells me. It tells me that the graph should have open circles or closed circles at ends, and then I'm filling in between, because that's what an and graph looks like. It tells me that numbers that have to work for the first one and they have to work for the second one. Okay, so there's a lot of things that that tells me with this and problem in number 1. So I'm just going to solve by adding 3 to both sides. So 2y greater than negative 8 divided by 2, and y is greater than negative 4. I divided by a positive, so that's perfectly fine. Okay? And add 3 to both sides. 2y less than 14 divided by 2. Y is less than 7. So I get y is greater than negative 4 and y is less than 7. Now I'm going to continue with this problem. That's solve the absolute value inequality. Step 2, graph the solution. So I've got this solution. I'm going to graph it. I've got a negative 4 and a 7. They're both open circles. I want the numbers that are bigger than negative 4 and less than 7. Well, again, just by logic that we thought of, that should fall in between those negative 4 and 7. Okay, so I graph the solution. And then the last part, I'll write the solution in interval notation. So I want interval notation which had brackets and parentheses. So a parenthesis at negative 4 as the beginning and a parenthesis at 7 as the end. That's interval notation. Okay, so there's all of problem 1. There should be enough room when you're actually writing on a piece of paper to do this, but if you find that there's not, then please go ahead and use a separate sheet of paper. Okay, we kind of already started number 4, so let's continue with it. This is going to split. Let's go back to the blue color here. This is going to split. I've got 4n minus 5. I'm going to do the negative, so the inequality switches. And then 4n minus 5 greater than or equal to the positive 1. This is an OR graph because it's greater, an OR graph. Okay, that's going to make a difference because I want to know that my graph is going to have endpoints, and the arrows generally are going to be going out. But it's going to mean that answers work in the first one or they work in the second one. They don't have to work in both. So I go through and solve these. 4n less than or equal to negative 10. Divide by 4. N is less than or equal to, I can reduce 10 over 4 to be negative 5 halves. There's an or in between. I'm going to add 5 to both sides. 4n greater than or equal to 20. Divide by 4. N is greater than or equal to 5. Okay, fractions are okay. I end up with a whole number here for the second one, and those are perfect. The second part, I'm going to graph these. So I've got negative 5 halves over here and 5 over here. They're both closed circles because they have the equal to underneath. I'm looking for the numbers that are less than negative 5 halves. That's this way to the left. And I'm looking for the numbers that are bigger than or equal to 5. That's this way to the right. Okay, so I have an OR graph. It actually matches what the word says with the OR has outside of the number line here. So in the last part, I want to write this as an inequality in interval notation rather. So this is a closed circle, so that's brackets, negative 5 halves as the starting point, 5 as the ending point, also with a bracket. Okay, so again, if you feel like you can't fit all of that in here in this one space, then please feel free to find a different place to go through and solve it. Just kind of jumping down, a reminder, here's number 7. I've got the absolute value. It's not by itself though, so I want to get it by itself before I split it. So I get 4x greater than negative 8. At this point, I could split it, but I notice that the absolute value and negative 8, I cannot take an absolute value and get a negative number. So that there's no way that this could happen. So this ends up being no solution. And we still have those options available to us. Okay, so no solutions. Number 8 though, when I look at this one, I'm going to multiply by 2 first. 3x minus 9, the 2's cancel. Absolute value less than or equal to 24. I multiplied by a positive, so the inequality didn't switch. Now I could go ahead and I could switch that, set that up so that I could get rid of the absolute value by creating 2 separate inequalities here. Let's look at one that's maybe a little bit different here, like number 11. I've got negative 2 absolute value, and again, when I look at this, I'm going to get the absolute value by itself by dividing by negative 2. When I divide by a negative, the inequality switches. 10 divided by negative 2 is negative 5. I have absolute value equal to a negative or less than a negative. Again, that's a situation where I want to stop and say, nope, that's not going to work out. That's no solution. Okay, but the same rules have applied from previous when we were solving equalities to this situation as well. So let's run down and look at one of the harder problems here. In this number 15, I need to get rid of the plus 3 and the 5 before I can get the absolute value by itself. So I need to subtract 3 first. So I get 5 absolute value of 5n plus 7, still greater than 18 minus 3 is 15. Now I'm going to divide by 5 to get rid of the 5 in front. So I get absolute value of 5n plus 7. Notice that nothing has changed inside the absolute value up to this point. Now I've got a situation where I can split this. The absolute value is by itself. So I get 5n plus 7. I'm going to make this the negative side so the inequality switches. And 5n plus 7 inequality stays the same because I'm leaving the answer positive. When I go through and solve both of these, I'm subtracting 7 from both sides, so 5n less than negative 10. Divide by 5, n is less than negative 2. This is a Gray-Tor problem. Again, Gray-Tor. And so Gray-Tor means that I'm going to put an or in between these two answers that I get. It also means it tells me a little bit about what my graph should look like. It tells me about what numbers should be working in this as solutions here. So subtract 7 from both sides, and this one, 5n greater than 3 minus 7 is negative 4. Divide by 5, and n is greater than negative 4/5. It's okay to have an n value that's negative. Notice that both of these are negative. That's okay. There's nothing wrong with that. The problem would be that if I were to take the absolute value, that I would get a negative answer out of that absolute value. So these answers are perfectly fine. Okay, so here's the first part. Second part is I want to graph those. So make sure that that you're putting these in the right places. Negative 2 is to the left, and negative 4/5 is really close to 0, so that's going to be to the right of the negative 2. I've got open circles at both of these. I'm looking for the numbers that are less than negative 2, that's this way. Or the numbers that are bigger than negative 4/5, that's this way. So when I look at those, I ultimately am looking at the fact that this is an OR graph. It has the endpoints and then arrows out to the sides. I start at negative 2 and I end at negative 4/5. Parentheses at both of those because of the fact that there's open circles, no equal to line underneath the inequality. Okay, so go through, work on these, make sure you ask questions if you have any of them.